So this is the beginning of Chapter 6, Exponential and Logarithmic Functions. So we're going to start out by talking about composite functions because this is the topic that both of these two fit into. And a composite function is a specially made function. So we're first going to talk about how to form a composite function. And then we're going to talk about how you find the domain of a composite function. So if we have two functions, f and g, then the composite function, denoted by f of g, or you can read it as f composed with g, and it's an f and an open circle and a g. And it's defined by f circle g means f of g of x. So it says put the g function inside of the f function. So the domain of this composed function that we've now created, it's a set of all numbers x in the domain of g that give you a g of x that's in the domain of f. So we'll talk more about that with specific functions. So I think of the function h of x that is created in this way as the function of a function. So f of g of x. So instead of putting a number into the function, we're putting another function in there. So there's lots of examples of things that are functions of functions. They're more complex. The relationship between the things is more complicated than a simple, say, linear relationship or quadratic relationship. So if you're talking about the volume of a balloon, you would be talking about the volume of a sphere, and it's 4/3 pi r cubed. That's the volume as a function of the radius. But then suppose the radius is changing as time is changing. So then you have a function that's a volume as a function of radius, which is a function of time. So you'd have 4/3 pi and then r of t, whatever that looked like, cubed. So maybe r is doubling every minute or something like that. So these are functions that you'll run across in calculus, and the important thing about recognizing them is you'll have a special rule that you use to do calculus with them called the chain rule. So you need to be able to recognize a function of a function. So here's another one, the spread of an oil leak. So if you're looking down on the oil leak, it would look like a circle, and the radius of the circle over time, the radius is going to be getting bigger and bigger of the oil spill. So you could have the radius might look like 200 times the square root of t. Well, then the area as a function of radius is pi r squared, right? So the area as a function of the radius, which is the function of time, is going to look like pi times 200 times the square root of t squared. So area is a function of radius, which is a function of time, a function of a function. So here's a little exercise where we're going to just practice with the notation, and here's a chart that says when x is -3, f of x is 11. So another way of writing this would be f of -3 equals 11. And remember, this tells us that the point -3, 11 is a point on the graph of this function. Okay, so the first one, f of g of 1, and I like to write it like this better, but you'll see all the problems in the book use the little circle notation. Well, I first look up g of 1, so I work from inside outward. So in this table, here's when the x value is 1. I come down here and see g of 1 is 0. So this tells me what's wanted is f of 0. So now I look at when x is 0 and say the f at that value is 5. Okay, so let's do a couple more and then we'll do some in class together too. So let's do B is f of g of 2. So g of 2, here's x is 2. Here's the value of g when x is 2. So this is f of negative 3. So now the input is negative 3. Here's the input of negative 3. And the f value when x is negative 3 is 11. Okay, so let's do one more and look for the patterns. So this one is g of f of 2. Okay, so let me erase some of this on the table so it's clean again. Okay, so g of f of 2. So we have x is 2, and I want f of 2 first now. So I want f of 2 is equal to 1. So this is g of 1. Need a little thinner tip, sorry. So g of 1, here's x is 1. Here's g of 1 is 0. Okay, so think about those and work out a few more, and we'll do some together in class too. So now we're going to look at, this is a function given in a table. Now we're going to look at functions given by equations, because remember we have lots of different ways of showing a function. Equations, graphs, maps, tables, lots of ways. Okay, so for number 18, here's the two functions you're given. And you're asked to find, for the A part, f of g of 4. So you could come over here and do as a separate side problem, g of 4. Well, g of 4 says put 4 into the g function where the x is, and you're going to get 12. So this is asking you for f of 12. Well, f says put the number 12 in absolute value and subtract 2. So this is going to be 10. So that's f of g of 4 for number 18. Okay, so then let's look at the B one, g of f of 2. Well, this says first do f of 2, because you're always going to look at the inside first. So, oops, I used the wrong function for the, sorry, this was confusing, wasn't it? Okay, so this is f of 12. I'm looking at number 18, sorry. So this is the square root of 12 plus 1, or the square root of 13. I mixed two problems together, sorry. Okay, so now we're still on problem number 18, B, g of f of 2. So we're going to do f of 2, which says put 2 into the f function where the x is, and you're going to get the square root of 3. So we come back over in here and say that means I want g of square root of 3. Well, here's the g function. So that says I want 3 times the square root of 3. So let's do the c, which is f of 1. So let's do f of 1 over here as a side problem. F of 1 is the square root of 1 plus 1, or the square root of 2. So this is f of the square root of 2. So that says put the square root of 2 plus 1 under a square root symbol, and you're done. So really, once you just find the pattern for this, it's really just a plugging in thing. It's not complicated. So we'll do number 20 together in class. Okay, so then the second objective is finding the domain of a composite function. So we're going to be finding a composite function. So we're going to be putting the function together first, and then finding its domain. So if I want to find the function f of g, I want f of g of x. Well, see how the g of x is inside the parentheses. So that says take this thing that is g of x and put it in the f function where you see the x. So 1 over, something's going to go in this box, plus 3. Well, the thing that goes in the box is negative 2 over x. Okay, so now we need to find its domain. So the domain of g of x is x just can't equal 0, right? So we definitely know we don't want x equals 0. But now look, we've made another denominator when we do the composite function. So we also need negative 2 over x plus 3 to not equal 0. All right, because we don't want 0 in this denominator either. So that's going to put a further restriction on the domain. So I want 3 to not equal 2 over x. So I want 3x to not equal 2, and I want x not equal to 2/3. So do you see that if you put 2/3 in as an x value, then you get a problem with the composite function. So the domain of the composed function is x not equal to 0 and x not equal to 2/3, because those both will cause problems. Okay, and then we'll look at this next example together and talk about what issues come up there. Okay, so to show that two composite functions are equal, you have to go both directions and show that f of g of x is equal to g of f of x, and that they both equal x. So f of g of x says take this g function and put it in here where the x is. So you can see you're going to have 3 times a third. That's going to be 1. So you're going to have 4 minus x, which is 4 minus 4 plus x when I distribute the negative, which is x. Yay! So we want to look at g of f of x. And that says take the f and put it inside the g. So I get 1/3 times 4 minus the quantity 4 minus 3x. So we do it's inside the parentheses first. 4 minus 4 plus 3x. The 4's cancel, and I get x. So this is how you show that two composite functions are equal. And then the last thing I want to look at is how do you compose a function? And there's lots of different ways of doing it. In this case, they say find two functions, f and g, so that if I put g inside of f, I'll get this function at the end here. So I could have g of x equal x squared, and then have f of x be the square root of 1 minus x. So see that if I put this g in here, I will get the h function. So another way of doing it, so this is a different way, would be to let g of x be 1 minus x squared, and let f of x just be the square root of x. So there's lots of different ways of composing functions, and in fact you could make this a three-way composed function. You could say let p of x equal x squared, then let q of x equal 1 minus x, and then let r of x equal the square root of x. So then r of q of p of x would be square root of 1 minus x squared. So that would be another way to write it. And that's it for this section, nice and short.